Alright, this is your Chapter 5 test corrections taken on May 13th, 2019. This is for versions B, K, and H for Brooklyn, Kaya, and Hadley. Test was out of 40. For question number 1, if you notice what I did here is I kind of just worked the problem out and then found my answer over here. Question number 1, you could have had either H or C for full credit, E, D, B, G, and then F. Question, the first one here, A, says tangent of negative 40. This is the negative angle identity. Tangent of negative theta equals negative tangent of theta. So if you put in your 40 there, your answer is tangent is equal to negative tangent of 40. So that would be none of these. So A wasn't used on any of those. Let me go through this column, then I can zoom in, and I can go to that one. Cotangent of 50 degrees is the cofunction identity. Cotangent of theta equals tangent of 90 minus the angle. So if they give you 50 as the angle, so that would essentially be tangent of 90 minus 50, so that would, the answer would be tangent of 40. So C, tangent of 40, would match this one. E, cosine squared of 105 degrees minus sine squared 105 degrees. Remember, if it helps you, write the formula right below it. Cosine 2x minus sine squared x. That's not the Pythagorean identity. That's the double angle identity for cosine. So cos 2x. Then your x is 105 here. So you multiply, you get cosine of 210, and that would be E. For cosine of 75 degrees, there's multiple ways you can think about it, but the answer is negative angle identities. Cosine of negative 75 degrees just means it's cosine of 75. So F matches this one. H, you have tan 90 minus tan 50 over 1 plus tan 90 over times tan 50. So you should recognize that this is the difference identity of tangent. If this is your A and your B value, then you're essentially subtracting those two. 90 minus 50 gives you tangent of 40. So H would also be number 1. Remember, again, these problems are kind of like working backwards. Let's go ahead and do the next column. For B, you have sine, cos, cosine. You have the sine sandwich. So it's sine. A is 45, B is 60. The question is, what do you do with those? Well, sine means the sign stays the same. So A plus B is 105. So your answer is sine of 105. D, you have cos, cos, sine, sine, ob, ob. So your A value is 150. Your B value is 60. Remember, for cosine, you are changing the sign. So 150 minus 60 is 90. Cosine of 90 is your answer. That would be choice D. For G, you have 2 tan 70 over 1 minus tangent squared 70. This is the double angle identity for tangent. So if you know your A value is 70, you multiply there, you have tangent of 140. And then J, none of these was never actually used. So you could have found the left column with everything up there. Remember, I skipped question number 7. Question number 8 and 10. Fill in the blank. It was a little bit difficult to read. It said 2 sine 7 pi over 12 times cosine of 7 pi over 12. Find the identity that kind of looks like it. So 2 sine x times cosine x. Therefore, your x value is, or the angle is 7 pi over 12. This is the double angle identity for sine. If you put in 7 over 12 there, and you multiplied, I accepted sine of 7 pi over 6. If you actually evaluated, negative 1/2, so I accepted either sine of 7 pi over 6. Negative 1/2, I accepted sine of 2x, or sine of 2 times 7 pi over 12. Any of those 4 answers would have given you 2 points. Question number 10. You should recognize you have a negative here, so this is the negative angle identity for sine. So that negative is actually just inside there. So sine of negative 35 degrees would give you the 2 points there. So these were either 2 or 0. Question number 9. Cos, sine, ob. So you have the difference identity, the sign changes, so you have plus, so you have the sum identity of cosine. So you would add A and B together. You would get cosine of 30 plus 45, so that means your answer would be cosine of 75. So I took any of these as full credit. Cosine of 30 plus 45, cosine of 75, or if you actually did the problem and got radical 6 minus radical 2 over 4, then you would have gotten 2 points. And then over here you just have the quotient identity, that is cotangent. Okay, the question number 7 you are not supposed to skip. Remember, it would have been really bad if you divided both sides by negative cosine. It would have eliminated an answer. You're supposed to add cosine of x to the left side. Take out the greatest common factor of cosine x. Set each of these equal to 0. You'll take the inverse. Where is cosine of an angle? Cosine of a position equals to the angle. Your position for cosine would be pi over 2 and 3 pi over 2. Pi over 2, cosine is 0. 3 pi over 2, cosine is 0. And then over here, where is cosine? Subtract 1 divided by 2. Where's cosine negative? It's positive here and here, so you're looking in this position. You're looking for 1/2. So for my counting technique, 1, 2, 3. So this is 1, 2, and 3. So this would be negative 1/2. This is 3 pi over 6, or pi over 2 and 3 pi over 6. So that's 4 pi over 6, which is 2 pi over 3. Use your counting technique. 1, 2, 3. 3, 2, 1. So this would be negative 1/2, comma, radical 3 over 2, negative. So this would be 9 pi over 6. 3 pi over 2 is 9 pi over 6. So this would be 8 pi over 6, or 4 pi over 3. So your two solutions added together would give you choice E. That side was out of 24 points, not 26. Backside. Verify the identity. Verify means you only work on one side. So a common mistake for students was working, common mistake was working on both sides. Now, I did say you can kind of cheat to see what's happening, but really I was looking for your work on one side of the identity. If you're just working on the left-hand side, if you multiply this out, you get 1 minus sine squared x. You can use FOIL or the box method. Recognize the middle terms will cancel. 1 minus sine x is cosine squared, and then cosine squared, using the Pythagorean identity, go from here and you go to the reciprocal identity. So I wanted to see actually go from here to there. Now, some of you guys are a little bit crazy, and you just wrote a bunch of stuff everywhere. You're like, Mr. Ring, you figure it out. But I'm not taking the test, I'm teaching the class. And I've taught you to be, like, coherent. So, you may have gotten 3 points because your work may have not been coherent. It's like you put me in the maze and you're like, Mr. Ring, figure it out. No. The test is for you to figure out. If you worked on the right-hand side, it's basically the opposite. 1 over secant squared x, use the reciprocal identity, and then you use the quotient identity, and then you would factor to the difference of squares, 1 plus sine x, 1 minus sine x. The number 1 mistake for the whole test is not knowing your identities, even though I let you guys use formula sheets. And number 2, another common mistake is cosine plus sine equals 1. A lot of students think this is the Pythagorean identity. That's not right. It's cosine squared plus sine squared equals 1. Question number 14. Use the sum and difference identity. So it's a formula on your formula sheet to find tangent of negative 15. I can't tell you, the common mistake was actually 2 numbers. People were finding 2 numbers that add or subtracted to be positive 15. Or 2 numbers that didn't even get close to 15. And I'm like, huh? Remember, try to pick numbers that are in the first quadrant. So I have 30 minus 45. Difference identity of tangent is tan A minus tangent B over 1 plus tangent A times tangent B. So if you wrote down the formula, I can give you 2 points. If you substitute in your values, you're basically going to get tangent of 30 minus tangent of 45 over 1 plus tangent of 30 and tangent of 45. Remember, you guys are allowed to use your unit circles on the test itself. So where's tangent of 30? Here's my unit circle. There's 30 degrees. Remember, tangent is sine over cosine by the quotient identity, or y over r. 1 over radical 3. And if you rationalize 1 over radical 3, you get radical 3 over 3. So tangent of 30 is radical 3 over 3. Tangent of 45, now this is not a negative tangent of 45, just think of tangent of 45. So you go to 45 degrees. Tangent is not on your unit circle, you have to derive it. That would be radical 2 over radical 2, which is a positive 1. So I put 1 for tangent of 45 here and here. To subtract radical 3 over 3 minus 1, I need a common denominator. This has a 3, so it changes to 3 over 3. So that becomes radical 3 minus 3 over 3. Here in the denominator, you have to multiply first. So that's radical 3 over 3 times 1, which is itself. And then I need that to add that to 1, so that becomes 3 plus radical 3 over 3. I'm going to change the division sign to write it sideways. So this expression divided by this expression. And then I'm changing the division sign to multiplication and taking the reciprocal of the second expression. You'll notice that your 3's will cancel because these are factors. You cannot cancel the radical 3's here because you have a plus and a minus, not multiplication. So you're left with radical 3 minus 3 all over 3 plus radical 3, and it gets more fun. You're going to have to rationalize by the conjugate. So 3 plus radical 3, then it's minus. You're going to have to use the box method to multiply. So either FOIL or the box method. So radical 3 minus 3, 3 minus radical 3. Think of this as like x. So 3 times radical 3 is like 3x, or 3 radical 3, negative 9. We're multiplying first. This positive times negative is negative. Radical 3 times radical 3 is radical 9. Radical 9 is 3. Negative times negative is a positive, so that becomes 3 radical 3. So you combine like terms here. You're going to get, you're adding now, so that would be 6 radical 3, or like 6x, and this would become negative 12. We're adding. And that's how I got this one here. 3 plus radical 3 times 3 minus radical 3, multiply, you get 9. 3 radical 3, negative 3 radical 3, and negative radical 9, which is negative 3. Combine like terms, these will cancel, and you're left with 9 minus 3, which is 6. Factor out a 6, and then you'll cancel out, and you'll recognize that you get negative 2 plus radical 3 is your correct answer. So 2 points if you knew the identity or you did the substitution. You got 3 points if you made a simplifying error somewhere in all the fractions there. Alright, so let's go over question number 15 and 16 on versions B, K, and H. So Brooklyn, Kaya, and Hadley, those were the 3, and then the other 2 versions were A and E for Autumn and Eloise. For question number 15, it says, given sine of beta equals negative 4/5, and negative pi over 2 is less than beta less than 0, find the exact value of cosine of 2 beta. What you should recognize is that you're trying to find the exact value of a double angle identity of cosine. Remember, there are 3 double angles for cosine. The question is, which of the 3 do you use? And the answer is, it does not matter, but one is more efficient than the other. For example, you're given sine of beta equals negative 4/5. In your double angle identities for cosine, although you could use this one, cosine squared theta minus sine squared theta, you would have to find cosine of theta, which would take you some work, wouldn't it? this one says you have to have cosine. So from sine, maybe use the Pythagorean identity. Or in this problem, it doesn't say you have to use identities. You can actually just draw your triangles. Does that make sense? Well, I thought the easiest one is, well, cosine of 2 beta, double angle identity for cosine, and that has sine in it. I'm just using this one right here. 1 minus 2 times sine squared theta. So, cosine of 2 beta equals 1 minus sine squared beta. Remember, sine squared beta is the same thing as sine beta squared. Right? So, let's try that again. It's 2 of them. Remember, if you don't like beta, you can just change it to your favorite Greek letter, theta, alpha, and x if you wanted to. And so all I'm doing there is just a substitution. Sine of beta is -4/5. And then here I'm just using the order of operations to simplify. Parentheses and exponents. So this means -4/5 times -4/5. That gives you 16/25. Then I'm going to multiply -2 times this. So -2 is a fraction by putting it over 1. So if you multiply across, you'll get -32/25. This 1 becomes 25/25. Then 25 minus 32 is -7. Cosine of 2 beta equals -7/25. Now, I did give you partial credit. If you found cosine of theta to be 3/5, I gave you 2 points. Again, you could have just drawn triangles, something like this. Sine is y over r. It tells you you're in quadrant 4 because the angle is between 0 and a -π/2, so you're coming in down in this direction. So here's my bow tie. And then your y value is going down, so that I know that's going to be negative. My r value is always positive. And if you knew something about the Pythagorean triples, you'll know that your x value is 3. And then you could have figured out with the other double angle identities for cosine, that cosine is 3/5. So if you just wrote down the formula, I gave you 2 points, or if you at least found cosine of theta, I give you 2 points. Question number 16. I'll just throw out the common mistakes first. On the other version, if you look at the other version of the other video, there's an equal sign here. What's the difference? You're adding fractions. When you add fractions, do you multiply by the conjugate? No, you have to have common denominator. So in this problem with the plus sign here, you have to have a common denominator. So the common mistake, CM, was that students were trying to multiply by like 1 plus sine of x. That would have been incorrect. The conjugate is transforming it, and what it does is it eliminates the middle term so you can use a Pythagorean identity. So multiplying by the conjugate actually does nothing in this problem. So that was a common mistake. How did I do this problem? You need a common denominator. This side has 1 minus sine of x. This one does not. So you multiply by 1 minus sine x over 1 minus sine x. You're multiplying by 1. This side I'm also multiplying by 1, but this side is missing a cosine. Cosine over cosine. Cosine of x times cosine of x gives me cosine squared x. Cosine of x times 1 minus sine of x, I don't need to distribute. On this side, a lot of students thought 1 minus sine x times 1 minus sine x was 1 minus sine squared x. That's wrong because you need to FOIL or multiply in the box. Watch. 1 minus sine of x, 1 minus sine of x. First you're going to multiply, then add. So 1 times 1 is 1, negative sine of x, negative sine of x, and negative times negative is a positive. Sine x times sine x gives you sine squared x. These two terms will cancel because they are like terms. No, they're not canceling. Forget the red. So negative 1 and a negative 1 gives you negative 2. So 1 negative 2 sine x plus sine squared x. We actually did this problem in the Earn Your Grade. Do you guys remember it? So if you guys thought about the whole test, you should have thought a lot of problems were really familiar. I either took it from your old quizzes and tests, or exactly from last year's test, or I took questions from your Earn Your Grade. I underline here sine squared x plus cosine squared x because these two is the Pythagorean identity. That equals 1. So if I add these two together, I put them over here together, that equals 1. So you're left with 1 plus 1 minus 2 sine x. 1 plus 1 is 2, so I have 2 minus 2 sine x. So if you look at this problem here, you'll notice they both have a 2. Think of it like this. 2 minus 2x. These are not like terms. You can factor out a 2. And that's what I did here. And the reason why I did that is because I have 1 minus sine x in the denominator. So multiplication, multiplication, then you can cancel. You're left with 2 over cosine x. So if you got 2 over cosine x, I give you full credit. Or if you wrote 2 secant x, then I gave you also full credit. So that side was out of 16. Some of you, I think, what I remember is that mostly students did very poorly in the backside in the free response. That wasn't end of the world because that side was only 16 points, and the front side was actually worth more. It was out of 24. And then your test was out of 40 points. Extra credit question answers were: school opened in 1961.